Alright, if you're watching this video, I'm going to assume you at least have some familiarity with the 8x8 LED matrices or maybe 7-segment displays. I'm not going to go into a lot of detail on these things, nor am I going to go into a lot of detail on how the 7219 LED controller works, other than to say that the 7219 is designed to drive groups of LEDs that are arranged with 8 cathodes and 8 anodes, and that's pretty much the limit of its capabilities. Now, generally that's not a significant limiting factor. I could, if I wanted to, say, drive 2 matrices, have a pair of 7219s, each one of them operating separately on one of the LED matrices. But my interest is in driving these 15-segment displays. Now, these are very similar to the 7-segment displays in that each cathode selects for one digit, but each anode selects which individual LED is lit up within that digit. So, if I wanted to light up the top LED on the left side, I would apply power to the appropriate anode, and I would ground the, I think it's pin 16 on to get the cathode for the left digit, and that one LED would light up. Let me show you why I have a special situation here with the 7219 and the 15-segment displays. So I'm just going to draw things 4x4 instead of 8x8, just to keep things simple, but you'll understand what I mean. So an LED matrix has 8 anodes and 8 cathodes. And if I want to light up a specific LED, all I have to do is apply power to the anode upon which that LED hangs and ground the appropriate cathode, and that will in fact light up this LED. If I wanted to also light up, say, this LED, I would apply power here and ground this cathode, and great, that LED comes on, but this one will as well, as will this one, because power here will sync through the LED to ground here and light up this one. Same thing here, power through here to ground here. I have an LED that's lighting up here. These two guys are ghosts and I don't want them on. Now, the trick that I had to come up with, because, let me put it this way. If I want to drive a 15-segment display, as I said, each digit is controlled by a single cathode, but each individual LED is controlled by an anode-cathode pair. Well, that means I kind of have this situation going on, where I have 8 cathodes, I have 15 anodes, but I can't just use a single 7219 on each side of this. And I hope you see why. It's a very similar problem to what we had up here. And I hope that I'm not off the screen. I'm not. Okay. So I cannot just attach each of these anodes to this 7219 and each of these to this 7219. And of course, each of these guys has its own control over cathodes, because the 7219s turn on LEDs one at a time. Each 7219 will have a program that tells it which LEDs to turn on. This one, say, wants to turn on this LED and this LED, but it goes through and it iterates through them. It finds that it needs to turn this one on, it applies power here, ground here, this one lights up very briefly, and then it moves on. It removes power here, removes ground here, and goes on to the next one. It needs to light this one, applies power, connects to ground, this LED lights up. But if I were to hook up 2 LED controllers to a 15-segment display with this kind of wiring, I think you can see what's going to happen. Sooner or later, the left 7219 is going to have this cathode grounded. The right one will have, say, this cathode grounded. And maybe, I don't know, maybe this one will be driving that anode, this one will be driving, doesn't matter, that anode. What will happen is, since both of these cathodes are grounded, this LED will light up, this LED will light up, this LED and this LED will all light up, even though the only ones that I intended to fire were these two. And so what I decided to do is, using transistors as switches, operate each 7219 in separate time. I switch back and forth between them. One of them will be allowed to operate for a very brief period of time, and then the other one will be allowed to operate for a very brief period of time. I think I'm switching back and forth at the moment at about 125 hertz. Now, the way that I accomplish this, each 7219 has this pin called RSet. And you not program, but you provide information to the 7219 about how bright you want it to display each pixel by how much current you put on RSet. So I have an Arduino sitting here that, using two separate pins, alternates power between these two RSets. For a 125th of a second, I will have power on this RSet, which means that I will be providing power to this anode. And in the next 125th of a second, I will have power on this RSet with none here. So I will have power on this anode, but none on this one. So that solves half my problem. I'm only powering the appropriate anode at any given time, but I'm still grounding cathodes that I do not want grounded. The way to fix that turned out to be to just take this same pin from the Arduino and have it connect to the base on transistors between the cathodes of the displays and the 7219, so that when I have power on this Arduino pin, power is allowed to flow out of these cathodes and into the 7219, but inversely, I should probably do my drawings properly. But while there's power on this pin, I do not have power on this pin, which means not only is there no power flowing this way through RSet and into the anodes, but I have effectively switched off these transistors, which does not allow these cathodes to sync to ground. So by switching back and forth between power on these two pins, I am alternating which of the 7219s is allowed to display. And your eyes can't tell the difference between, well, your eyes cannot distinguish that this flashing back and forth is anything other than having those LEDs on all the time. Now, this is just a very basic demo, but it is here to show that I am in fact powering the lower half of each digit, while apparently at the same time I am powering the upper half, and I can select back and forth between the two digits just by telling the 7219s which digit is currently on and off. I really hope this is making sense, but this basic circuit demonstrates everything that I need out of this behavior. Now, what I want to do with it is, since, like I said, maybe I didn't, I have too many of these things lying around, so I might as well use them. I'm going to use the mini board service from PCB Express to create modules that I can use in a larger project, where the point is to have about a dozen displays like this, where I have 8 digits in a bundle, and each bundle will be controlled by some small board that I'm going to create that drives that set of displays. I'm hoping actually that I can fit, say, maybe 4 of these controller modules onto a single PCB. I kind of doubt it, because each one of them is going to have to host 2 of these guys, 16 transistors, and at least 2 resistors, and enough headers to support 20 pins, maybe more. So maybe it'll be more like a third of a board. Hopefully it won't be half a board, because I want these things to be fairly small. But anyway, that is what I'm up to. I will be using this circuit as my model when I go to PCB Express to design the circuit. The difference between this and the actual module that I'm going to design isn't that great. It's just the extra 6 transistors on each 7219 so that I can get more cathodes in there. It would be fairly trivial to add the extra digits to this thing. I just hate wiring on breadboards, so I haven't done it. So anyway, that's where I am. I hope that made sense. Probably not, but if it didn't, leave some comments in the display, or in the leave some comments below, and I will do what I can to answer any questions. In the meantime, I will be designing circuits in PCB Express, and hopefully have another video before you too long. Anyway, take care.